back to my channel, and today I'm going to solve Cambridge O-Level past papers 5070/12 of October-November 2019. So it is a multiple choice question paper. Let's solve it together. So MCQ number 1 is the concentration of aqueous sodium carbonate can be found by reaction with hydrochloric acid of known concentration. The indicator methyl orange is used. So we're going to select from all of these options which option contains the apparatuses that are supposed to be used. So as we can see, sodium carbonate is used over here, which is in aqueous form, and hydrochloric acid, which is once again in liquid form of a known concentration. So basically for this is quite similar to its things are very similar, reagents are very similar to a titration method, and for titration we usually use a burette, a pipette, and a conical flask. That is what we usually use, but we'll go through the options. So burette, yes, we can use burette. Measuring cylinder, no, I don't think so, because I don't believe that we're going to use measuring cylinder, mainly because there is no purpose of measuring cylinder. We are supposed to know the concentration. We're not measuring something in a cylinder. And a gas syringe, there's no need of gas syringe, because we are not once again checking at the rate of reaction or something of the gas, that is carbon dioxide, that might escape. So A is not the right option. Then burette, definitely measuring cylinder. Once again, we're not using measuring cylinder, so automatically come to the next option. But I'll still tell you why we do not need thermometer, because there is no requirement of temperature checking for knowing the concentration of aqueous sodium carbonate. I recommend you to underline this word, to bold this word. However, you can just mention it. Coming to C, burette, pipette, and conical flask. So yes, this is the right option as we judged before. So C is the right answer for this. D, once again burette, but pipette is also used. However, stopwatch, there is no requirement. Once again, we're not checking the rate of reaction. Question number 2. The diagrams show three stages 1, 2, and 3 used in the preparation of a salt. Which row correctly shows the solubilities of both of the reactants and of the salt formed in this preparation? So for this, let's go and see. So here we are told about the solubility of the reactants and the solubility of the salt formed if we use these methods. So for this, we're gonna look first of all here. They are adding the reactant. These are two reactants that are being mixed together, then filtered out and heated. Okay, so for this, definitely first of all look at the first stage. They're being reacted. That means probably they'll dissolve, they'll form a new product and all that thing. Then if we come on number 2, so over here there is a residue, which is definitely an insoluble salt formed in here, because it doesn't get dissolved, so it won't pass the filter paper. So residues are always, remember, the residue is always an insoluble salt. So it's definitely going to be an insoluble salt here. Then coming to 3, we have provided heat to the filtrate over here, which is mentioned, and the final salt that comes out is after the heating process, after the evaporation process. The leftover salt is basically the final salt. So let's go through the options. Both of them are soluble. Both of them cannot be soluble, because if they were soluble then there wouldn't be any residue, but now that there is residue, that means they're both not soluble. So probably these two options are not possible. Then C, one soluble and one insoluble. Yes, this is possible, because one is soluble, the soluble salt is formed here after the evaporation, and residue is the insoluble salt. So one soluble and one insoluble, and the solubility of the salt formed, well, here it is written insoluble, but once again it is not insoluble, as I told you over here that a soluble salt is formed over here after the whole heating process and evaporation process. A salt is left behind which was soluble, that is why it dissolved, that is why the salt formed is soluble. So the last option is going to be the right option. So the answer is D. Moving over to question number 3, the nucleon number of an atom is typically greater than its proton number. The difference between these two numbers indicates the number of 1 in the atom. Atoms that have different nucleon numbers but the same proton numbers are called. Which word correctly completes gaps 1 and 2? So a nucleon number of an atom is typically greater than its proton number, which you already know, because it is the sum of proton number, and nucleon number is the sum of proton number. And the neutron number, however, when we talk about the difference between these two numbers, indicates the number of dash in the atom. They're talking about the difference between nucleon number, and they're talking about the difference between nucleon number and proton number. So for this, of course, whenever you subtract the total nucleon number, what is nucleon number basically? Nucleon numbers are the total amount of protons and neutrons present in a nucleus. I repeat, we are talking about the nucleus only. A nucleus contains a proton and a neutron, nothing else. So over here, as you can see, proton number is already mentioned, but if we subtract nucleon number, that is, nucleon number is a sum, so if we subtract proton number from the nucleon number, that is the total nucleus, then we are definitely going to get neutron number. If you want me to explain it a bit more mathematically, so it could be in this way, that nucleon number is equals to proton number plus neutron number. So ultimately, if proton number is shifted towards the other side, so it is nucleon number minus proton number, and it is equals to the nucleus in the atom, number of nucleus in the atom. So it's gonna be nucleus, number of neutrons in a nucleus. I'm sorry, a bit confusing words they are, so I'm again repeating it for you all. Nucleon number minus proton number is equals to the neutron number. Now I got it right. So number 1 is going to be neutron, which is not electron, so it's going to be either C or D. Let's see the further statement. Atoms that have different nucleon numbers but the same proton number are called. Here, make sure you have seen these were different nucleon numbers. That means nucleon number can be changed, but same proton number. So basically, this is a fact that remains for all atoms, that their proton number is their identity, and your identity cannot be changed. So talking about proton number can never ever be changed. If there is a change in the proton number, that means you're talking about a totally different element or an atom. So it's definitely not proton number that will ever change. So this is basically a terminology for atoms that have different nucleon number but the same proton number. That means nucleon number is different but proton number is same. Mainly it tells you that it has some sort of shuffling or some sort of changes made in the neutron number. So when there are changes in neutron number, so it is basically the isotope of the same element. That means carbon 12, carbon 13 and carbon 14. Carbon 12 is basically, it's an example. Carbon 12 is having 12 protons, which is not correct, sorry, 12 nucleon number. Again, carbon has 12 nucleon number and 6 proton number. I don't have the periodic table right in front of me, so I'm just trying to recall. So I'm I'm sorry for the little mistakes that I just made, but now I hope I won't make them. So basically carbon 12 is the 12th nucleon number, that is proton plus neutron, and the proton number of carbon is 6. So when we subtract 6 with 12, we are getting 6. So it has 6 neutron numbers, 6 proton number, and 12 is a nucleon number. Then when coming to the second atom, that is carbon 13, that means proton number is same because it is carbon. We can easily say that proton number is not changed because it is the same element, that is carbon. But carbon 13 has 7 neutrons in it, and carbon 14 has 8 neutrons in it. So it's the neutrons that is changing, and carbon 12, 13, 14 are isotopes of carbon basically. So the answer is D. Question number 4. Which 3 elements exist as a diatomic molecules at room temperature? Hydrogen, oxygen, helium, nitrogen, chlorine, neon, nitrogen, oxygen, chlorine. So these are the options. We're going to select one of them on the basis of the requirement of the question. So let's see. We're talking about 3 elements over here. Of course, there are only 3 options, by the way, in every option. Only three gases mentioned in every option. So let's see. It exists as a diatomic molecule. Diatomic molecule. Here is where the main thing comes. At room temperature. Room temperature means in normal condition without any heating or some cooling process. When it is at normal conditions, room temperatures are usually 25 degrees Celsius to 26 degrees Celsius. So at this temperature, they are in diatomic form. So it's not gonna be helium, definitely not gonna be helium, because helium is a noble gas and it doesn't actually form a diatomic molecule. Then coming to nitrogen, yes. Chlorine, yes, but again neon is a noble gas, doesn't form any type of molecule. Then coming to part C, nitrogen, yes, oxygen, yes, and fluorine, yes. Fluorine is in group 7, oxygen in group 6, and nitrogen in group 5, and all of these 3 of them are in diatomic structure, diatomic molecule when we are talking about room temperature. So C is the right answer. Moving on to next, question number 5, which is a pure compound. So from these options we're going to tell which is a pure compound. That means there's no such impurity in it. So dry air, once again, dry air has many things in it. It's not only one compound, but there are several compounds in air. So it's not dry air. If you come to ethanol, so ethanol is basically, you might have studied in organic chemistry, ethanol is an alcohol and it is one compound, not many compounds. So definitely it's gonna be ethanol. But let's see part C and D. C is steel. Steel is an alloy. An alloy has many elements and compounds mixed together to form steel. And petrol, once again, it's not a pure compound. So definitely B is the right answer. Coming to question number 6. Which diagram best represents the structure of a solid metal? Solid metal, it's like very clear from the whole diagram. We can see from all of these 4 that this is one of the most easiest questions which you will get. So A is not the right answer because they're not randomly scattered like this. Neither can C be the answer because they're not that well arranged. They have a sea of electrons around it and positive ions are together. It's not D because there are electrons in the between as well. So it's definitely B, because B has a sea of electrons in and out and everywhere. So it's basically what makes it conductive and even it's even easy to bend and it's malleable and ductile and all that stuff. Question number 7. Hydrogen sulfide burns in an excess of oxygen according to the equation shown. 48 dm cube of hydrogen sulfide is burned. Which volume of sulfur dioxide will be formed at room temperature and pressure? All volumes are measured at the same temperature and pressure. That means there are no changes in pressure, no changes in temperature. So basically this is a moles question, and in this hydrogen sulfide is being burned. So the whole equation, we have this ratio of 2:3:2:2. So if we burn 48 dm cube of hydrogen sulfide, that is this, we are supposed to find sulfur dioxide. How much sulfur dioxide will be formed? So basically hydrogen sulfide and sulfur dioxide have the same mole ratio, that is 1:1 ratio. So I think this is a question in which you require calculation. So you calculate it while I'll wait for you. Calculate it as soon as possible, and then we will share the answers. I hope you have solved it. So basically this question had the simple trick in it that it has the same moles. So probably at the same temperature and pressure, it is more likely to have the same volume present at the same pressure and same temperature. So the answer is gonna be 48, and it's C. So I hope you all understood it. Now coming to question number 8, which statement about electrical conductivity is correct? About electrical conductivity, covalent compounds such as glucose conduct when molten or dissolved in water, which is definitely not right, because they basically do not conduct electricity in the form. Coming to dilute acids such as sulfuric acid conduct because all the ions are free to move. So this is the right answer, because dilute acid means there is water in it. When there is water in something, it is ionized. When they are ionized, so they have free ions that are free to move, so they carry the whole electricity, they carry the charge, and they transfer it. So in one way they're conducting electricity. Coming to part C, ionic compounds such as sodium chloride conduct due to the movement of electrons. Well, sodium chloride does not have a lot of electrons, like quite negligible amount of free electrons. I'm talking about the free electrons only. It has electrons but does not have free electrons, so that is why it's not gonna be C. And metals such as copper conduct due to the movement of positive ions. So positive ions are stationary, they're not moving. However, the sea of electron around it is moving. That conducts the electricity. So answer is definitely not D. So basically the answer of question number 8 is B. Coming to question number 9. Ammonia is manufactured from nitrogen and hydrogen by the Haber process. What is the percentage yield when 60 kg of ammonia is produced from 60 kg of hydrogen? So 60 kg of ammonia is produced from 60 kg of hydrogen. Here we have nitrogen, here we have ammonia. We are supposed to find the percentage yield. So guys, I hope you're all calculating it. I'll once again give you some time for the calculation. So guys, I hope you've calculated it, and let's go back to the question. Do share your answers in the comment box below. I will see them, and I'll see how well do you know chemistry. Anyways, the answer for this question according to my calculations is B, that is 17.6%. So coming to the last question of part 1. What is the ratio of number of molecules in 71 gram of gaseous chlorine to the number of molecules in 2 gram of hydrogen? So guys, this question, once again, there's calculation in it. Go ahead, calculate it. I give you a few seconds. If you haven't done it, pause it right now. Okay, so I'm going to tell the answer. 71 gram of chlorine is basically, here once again the keyword is gaseous chlorine. Chlorine, once again, as I told you above, it is a gaseous product. It is a gaseous molecule, and basically it has 35.5 atomic mass. So when they're found in gaseous form, they're basically found at room temperature in this form, and they're diatomic. So 35.5 plus 35.5 is equals to 71 gram. That means one chlorine, I repeat, one chlorine that has 2 chlorine in it, one gaseous chlorine that has 2 chlorine atoms in it, combined to form 71 gram massed product. And then coming to hydrogen, hydrogen has the same case, chlorine to the number of molecules of gaseous hydrogen. Hydrogen is H2. One hydrogen is equals to 1, other hydrogen is equals to 1, so 1 plus 1 is equals to 2. So in this way, if we get to know, so there is one chlorine and there is one hydrogen, which clearly makes a ratio of A1:1. So this is it for the first part. We'll do the next 10 MCQs in the second part and the further ones in the next part. Make sure you have subscribed my channel if you want to stay updated. Ring the bell icon, like, comment, share the video with your friends, and make sure you take the full advantage of these things. If you have any sort of query, you want any topic to be discussed, anything you want should be discussed, make sure you let me know. Any papers, something at all. And even this paper was on someone's request, which I really appreciate that people are requesting in the comment box below. And this is great to see that you are all willing to study and gain good marks in your exam. It's high time, exams are very close, less than 100 days are left for your papers. So just struggle, work hard, and I know you can all ace it. Best of luck and keep working hard.